This tutorial is the first in a series that will show you how to use the AnimatLab Software Developers Kit to build your own plugin modules that can be used within AnimatLab. I will begin by showing you how to install the AnimatLab SDK, and then I'll briefly go over the various libraries and files that are included, and then conclude with an outline of the major classes and what they do. In the following tutorials, I will show you how to create your own custom AnimatLab projects. Before installing the AnimatLab SDK, there are a few things that you'll need. First, you must install the AnimatLab application before you attempt to install the SDK. The application installs the correct version of the .NET and DirectX libraries that are required for the projects in the SDK to compile correctly. Second, you'll need to have a copy of Visual Studio 7 or 2003 installed on your computer. The current version of the SDK will only compile and run using Visual Studio 7. It will not compile with versions 8 or 9. Unfortunately, Visual Studio 7 will not install on Windows Vista, so you'll need an XP machine. I realize that this may cause problems for some people, and I'm sorry, but the older versions of Vortex that we're currently using will not link correctly in the newer versions of Visual Studio. The next version of the AnimatLab software will be upgraded to use the latest versions of Vortex and Visual Studio, but for now, we're stuck with version 7. Third, if you want to be able to get any of the newest changes to the AnimatLab code, you'll need to install the Tortoise SVN application. This program is a Subversion source code control system. AnimatLab code is open source and is available free of charge on Google Code. Tortoise SVN links up to the Google Code server and allows you to download the most up-to-date versions of the source code. You can find a link to download the Tortoise SVN application on the AnimatLab SDK webpage. Finally, you'll need the SDK itself. You can download the SDK by clicking on the AnimatLab SDK link in the toolbar on the AnimatLab website. Once you've downloaded it, you'll need to run it and then follow the instructions. They're pretty easy. Just pick where you want the file saved or use the default location. After the SDK has been installed, you'll see that the AnimatLab SDK folder appears in the location that you chose. If you have installed Tortoise SVN, then a green checkmark will be visible on the directory icon. This is an SVN icon overlay. You can use SVN to make sure that you have the latest code by right-clicking on the folder and then going to the SVN update item. This will automatically connect to the Google Code repository for AnimatLab and download the latest code. One thing that you should keep in mind, though, is that this only gives you read access to the AnimatLab source code. I'll talk more about this a little bit later. Within the SDK folder, there are a number of directories and files. I'll begin by explaining what each directory contains. The first is called AnimatLab. This contains the project for the AnimatLab.exe application. However, you should never compile this application. The executable is simply a shell that instantiates the application plugin module. There are some licenses that are linked to the signature of the exe binary file. So if you recompile this project, it will overwrite the binary and the physics engine will no longer work. If you accidentally do this, then you'll need to copy the AnimatLab.exe from the program installation folder into the SDK bin folder for the system to work again. I'm providing this code in case you're curious as to how it works. The next folder is bin. This folder is where all of the binaries and dynamic link libraries are stored. When AnimatLab starts running, one of the first things it does is to look through all of the DLLs in its executing folder and see if any of them are .NET and have classes that are derived from the AnimatLab base classes. If it does, then it plugs them into the application so that they can be used. So all you have to do to add new functionality to AnimatLab is to create the appropriate classes in the DLL and then drop them into the bin folder. AnimatLab will automatically see it and make it available for use within the application. The include folder contains all of the global include files for the C++ simulation libraries. When you create a new AnimatLab project, you will need to link your project with the existing libraries in order to use their interfaces so that your project can plug into AnimatLab. These include files are what allow you to do this. They have the information that the new project needs to know the structure of the base classes and the appropriate lib files that are needed. The lib folder is similar to the include folder. When you create a new project that is based on AnimatLab code, you need to link to the appropriate lib file. This folder is the global repository for those lib files. Next, the libraries folder is where all of the code for the AnimatLab plugin modules is stored. There are numerous libraries that make up the entire application. First, I would like to discuss a little bit about how the AnimatLab system is structured. One of the more important concepts is that the user interface and the simulation code are completely separated. The simulation code knows nothing about the user interface. The simulation code does create and open the simulation window to display the results of the simulation, but it can run and open that window in a completely standalone fashion without even having the AnimatLab GUI application running. When you run the simulation within the AnimatLab GUI, the program supplies the simulator with a window that it can use to display the simulation within the user interface system. The user interface first creates the simulation window within the GUI and then passes the HWind pointer to the simulation system. The simulator then creates its window using the HWind pointer given to it by the GUI. However, the UI components do know something about the simulator system. They know the file structure used by the simulator. So when you start a simulation, the UI components save the configuration to an in-memory XML string, so the UI components need to know how to save out the XML configuration that's needed by the simulation objects. It then passes that XML string to the simulation system using the load method. This allows the simulator to load and initialize all of its structures. But otherwise, there's no direct connection between the UI and the simulation components. This was done deliberately in order to cut the links between the UI components and the simulation components. If this separation was not made, and the simulation components also had to deal with UI features, then it would add a great deal of overhead to the simulation objects and slow them down. We wanted the simulation system to be as freestanding and as fast as possible, but neuromechanical systems are so complicated that the user interface is a necessity for them to be accessible to a wide user base. We also felt that it was important to have the simulation source code written entirely in C++ for speed purposes, but C++ is not really the easiest language to use for building user interfaces. Instead, the user interface was written in the Visual Studio .NET languages. Most of the UI code was written in VB.NET, but some components were written in C#. We felt that this was the best way to approach the problems of making the simulation as fast as possible, while simultaneously making it easy to build a user interface. Using the .NET languages to build the user interface also allowed us to use third-party controls. This made building things like the data charts and behavioral and body editors much easier. What this means for you, the developer, is that when you want to add a new plugin module to AnimatLab, you actually have to add two components. The first is the simulation component, and the second is the user interface component. Also, since the user interface is .NET and the simulation is C++, this means that these two components are in separate Visual Studio projects. Within AnimatLab, naming conventions has been that the user interface projects end with the word tools. We probably should have used UI, but it would be a major challenge to go back and change this now. The other libraries are C++ simulation projects. They typically end with the word library, but this has not been as consistent as the tools ending. You should always see a pair of projects with similar names like Animat Tools for the UI and Animat Library for the simulation components. Now, let's open up the core code for AnimatLab. To do this, go into the Animat Tools folder and double-click the animattools.sln solution file. This solution contains all of the main simulation and user interface projects for AnimatLab. Unlike the animatlab.exe project, you can recompile this project anytime you want. However, you should refrain from ever making any changes to the code of any project within this solution. The reason is that even though you make changes here and compile it so that it works with your project, that change has not been made to the master code. So when you get an updated version of AnimatLab from us, then it will no longer contain those changes and your code will break. If you ever have suggestions for new features and changes that you would like to see added to AnimatLab, then you can contact the AnimatLab administrator for approval to make the additions. If the changes are approved, then we'll create an SVN account for you and allow you to upload your changes to the source code repository. When you upload your changes, they do become a permanent part of the core AnimatLab source code and are distributed to all users of AnimatLab. If you want to do this, you can reach the administrator by clicking on the email address link listed at the bottom of each page on the animatlab.com website. However, this does not mean that you have to have our permission to make new plugin modules for AnimatLab. Doing that does not require changes to the core libraries. You simply need to create a new project that's built on top of the core libraries. While this solution is loading, let's look at the remaining directory in the SDK. This is the Utilities folder. The Utilities directory contains a couple of useful utility applications that may help you. The first is Animat Wizard. This is a standalone wizard that will automatically create AnimatLab projects for you. It creates all of the project and source files that you will need to get a number of different types of projects up and running immediately. For example, you can use this to create a new neural plugin module system, or new sensors, stimuli, or a new muscle model. I'll be going over this application in detail in the next tutorial. The second application is SimRunner. AnimatLab was written specifically so that it could be automated and run on grid or parallel processing systems. However, not everyone has access to these types of systems, and it may still be really helpful to run a series of scripts automatically. An example of where this would be useful is if you wanted to vary a set of parameters over a range of values and run the simulation for each one so that you could compare the change in behavior that results. This application lets you do that. You can create a program module that will save out a series of project files and then use SimRunner to execute all of them sequentially on your own machine. Of course, this is not as fast as running it on a parallel processing grid system, but it does automate the entire process so that you can vary parameters systematically and have the simulations run overnight unattended. I'll be going over how to use this system in a later tutorial. Now, I'd like to go over the different library projects that make up AnimatLab. The first library I'd like to talk about is the standard utils library. This is a C++ foundation library that has numerous utility functions and classes that are used throughout the system. One example of a foundational class that is used throughout is the XML class that's used to read and write XML objects. Microsoft has some standard classes that perform similar functions, but the simulation code is based on the standard template libraries and is code independent from Microsoft. At some point in the future, we'd like to port the simulator over to run on Unix and Mac systems. To do this, it's important not to rely on Microsoft-specific code models. Also, I personally found Microsoft's XML system to be very cumbersome and difficult to understand. Magic Library is another foundational library, but for .NET this time. This is a project that I found online at codeproject.com, and I really liked it, so I've modified and added to it extensively for use within AnimatLab. It provides a lot of the Windows functionality, like the windows and toolbar docking, and so on, that helps make AnimatLab so versatile. Animat Library is the core library for Animat simulation projects. It has all of the core interfaces and base classes that are needed. All of the other simulation library projects are derived from this library. Just as the Animat library is the core for the simulation system, Animat Tools is the core for the UI system. All the other UI projects are derived from this library. Fast Neural Net is the simulation neural module plugin for the firing rate neural model, and Fast Neural Net Tools is its UI components library. Similarly, Realistic Neural Net is the simulation neural module plugin for the integrate and fire neural model, and Realistic Neural Net Tools is its corresponding user interface assembly. Vortex Animat Library is the simulation library that contains all of the Vortex physics engine components that define the rigid bodies, joints, and simulation environment. Vortex Animat Tools is its UI assembly component. Licensed Animat Tools has UI components for graphing. This project has licensed third-party .NET tools in it, and it may not compile for you unless you have purchased those components. If this is the case, then you will need to remove this project from the solution in order to compile the Animat Tools solution. However, I wanted to provide the code for you to be able to look at. Finally, Managed Animat Tools is what links the C++ simulation libraries and the .NET user interface system. This is a managed C++ component that uses unmanaged code within it to access the simulation components. This lets the .NET system control the simulation. Next, I'd like to briefly go over some of the important classes and the structure of the source code for both the simulator and the user interface components. This will be a very high-level overview. I will begin with the simulator. Let's open up the class view for the Animat Library project. All Animat projects utilize namespaces to separate the code into functional components. At the root namespace, the most important object is the simulator class. This is the class that manages all of the objects within the entire simulation. It's the root object where everything begins. All objects within the simulation environment have several key steps they go through for simulation to progress. After the simulation object has been created, the first thing that is done is that all of the parts beneath it are loaded using the XML configuration data that was created by the user interface objects. This is done through the load method of each object. This creates and loads all of the objects and all of their parameters. The next phase is initialization. A number of the objects have to get pointers to other objects within the system. For example, a synapse will need to get a pointer to its presynaptic cell, or a data chart will need to get a pointer to the data it will be storing, and so on. This type of stuff is done within the initialization phase after all of the objects have been created. Next, the simulation begins. Each object involved within the simulation has a step simulation method that is called at each time slice so that its portion of the simulation can be calculated. Finally, once the user ends the simulation, there is the object destructor for each class that cleans up any allocated memory. Starting at the top of the namespace, we see the adapter classes. These objects are used to transform data in a neural module into values that can be understood by the physics engine or other neural engines, or vice versa. The behavior namespace is next. It contains the nervous system. The nervous system is composed of multiple neural modules. This allows you to mix, integrate, and firing rate neurons within the same organism. Each type has its own neural module that is processed separately, and adapters allow communication between the different types. Neural module is the base class for the neural module plugins that you, as a developer, will create and implement for your own neural system. The charting namespace contains the classes needed to record parameters from any object within the system. Data is obtained from objects by using the virtual getDataPointer method. The config file specifies the specific object that has the needed data. A call to its getDataPointer method passes in a string name of the data that is needed, and a float pointer is passed back that shows the value of that data item throughout the simulation. This provides a generic method of getting data from any object. This mechanism is used not only by the charting system, but also used internally for communications between objects, because it eliminates the need to use mutator accessor functions. Using these types of functions to access data is slightly cleaner at compile time, but it makes it necessary for the base classes to know the full class definition, and this is not possible with plugin modules. For example, say you create a new muscle model with the parameter KDD. As long as you have derived your muscle from the appropriate base class and added the KDD variable to your getDataPointer method, then the underlying base classes do not have to know anything about the accessor or mutator functions on your new derived class. The environment namespace has classes that are related to the physical components of the simulation. The most important class is structure. Structure is the base class for any object within the environment. It contains a rigid body object, and that rigid body has child bodies and joints that connect them to each other. Organism is derived from the structure. It is different in that it has both a physical structure and a nervous system. Underneath environment, there are two sub-namespaces for bodies and joints. These namespaces contain the base classes for all of the body parts and joints. The external stimuli namespace contains classes that are involved with adding stimuli to different body parts and neural systems, while the gains namespaces contains the available gain function classes that can be used within AnimatLab. An example of where you would see a gain is when you set up an adapter. It may be that none of these provide you with the type of function that you really require. You can add a new one by creating a new gain type in your project, and it will show up in the list of available gains within the adapter. Next, let's look at the structure of the user interface components. The namespaces used within the UI system closely parallel those within the simulation system, with some minor differences. The first difference is that there is a namespace for collections. There are a few collection base classes that all other collections are derived from, and these are stored here. The framework namespace is where the Animat foundational and utility classes are kept. These are some of the most basic classes that virtually everything is derived from. For example, within the UI system, all of the items that correspond directly with the simulation classes are derived from the data object class, while all of the forms are derived from the Animat form class. Scaled number is a class that you will see often throughout the code. It's what allows the user to specify parameters using units within the property grids. So, in other words, this lets them put in 5 millivolts instead of just having to specify 0.050 with no description. Image Manager is a class that manages all of the images that are used by the application. All images within the AnimatLab project must be embedded as a resource. I will show you how to do this in a later tutorial. The Util class has a number of very useful functions, and it also has global access to several important global classes like the application and simulation objects. As I mentioned, all of the non-form objects are derived from data object. Data object provides a great deal of under-the-cover functionality. For example, it has code that lets objects display within the property grids, and it lets the history system keep track of any changes made to it. Within data objects, there is the behavior namespace that contains the items related to the neural network system. For example, all items like neurons that show up in the behavior editors are derived from node, while connections between items are made using objects derived from link. Within the behavior namespace, there are subspaces for specific nodes and links. Forms contains any forms that will be displayed to the user. The root form is the Animat application. This is the form that is created when the program starts, and it contains all objects within the entire system. Otherwise, forms are split up according to their functionality. This has been a basic overview of the structure of the libraries and classes within AnimatLab source code. I have, of course, only scratched the surface as to how everything works and interacts with each other. But this should give you a basic idea of what the classes are and what they do. In the next tutorial, I'll be going over the Animat Wizard application to show you how to create your own custom AnimatLab projects.